Avon, Connecticut, July 29, 2005. A Friday morning commute on Route 44, the road locals call Avon Mountain, a 500-foot hill that drops toward a traffic light where two state highways meet. At 7:30 a.m., a Mack dump truck loaded with dirt and gravel crested the top of the grade and began its descent. The truck weighed more than 15 tons. Its brakes had been cited for violations the year before. Its owner knew. The driver pressed the pedal and nothing answered. The truck went airborne briefly at the bottom of the hill, crossed into oncoming traffic, and struck a commuter bus and 18 cars in a chain reaction collision that killed 4 people, injured 23, and set vehicles on fire for a quarter mile. This is not a story about one crash. This is the story of why heavy trucks were never designed to stop, and how a century of engineering, economics, and gravity conspired to make a 7.5-ton machine the most dangerous object on any American mountain road. The physics are not complicated. A loaded commercial truck, Class 8 the legal maximum, can weigh 80,000 pounds. At highway speed on flat ground, that truck needs 20 to 40% more distance to stop than a passenger car. On a 6% downhill grade, the math changes entirely. Gravity pulls the load forward at a rate the braking system was never designed to resist for sustained distances. Every mile of descent adds heat. Every degree of heat degrades the brake material. And the margin between controlled deceleration and total failure narrows with every switchback. This is not a new problem. It is one of the oldest problems in motorized transport. Older than the interstate highway system. Older than the diesel engine. Older than the regulatory agencies tasked with preventing it. And the vehicle that came to embody both the promise and the peril of American heavy hauling was the Mack truck. The Mack brothers, Jack and Gus, built their first commercial vehicle in Brooklyn in 1900. A 40-horsepower, 20-passenger bus, chain-driven, with a Mack-built 4-cylinder engine. By 1905, the brothers had moved operations to Allentown, Pennsylvania, and begun producing dedicated heavy-duty trucks, 1.5 to 5-ton haulers with seat-over engine cabs designed for visibility in crowded city streets. The Mack AC, introduced in 1916, earned its reputation in the mud of the Western Front. British soldiers called it the Bulldog. It weighed 7.5 tons fully loaded and could haul artillery across terrain that killed horses. It was the toughest machine on the battlefield. But it was not built for mountains. It was built for flat, slow, punishing work. And the braking system reflected that assumption. The earliest truck brakes were mechanical. Steel shoes pressed against a drum by rods and cables. They worked adequately at low speeds on level ground. They failed predictably on grades. The core mechanism was friction, and friction generates heat. The longer you brake, the hotter the drum gets. At a certain temperature, around 500 degrees Fahrenheit, the friction coefficient inverts. The brake shoe slides instead of gripping. The industry calls this brake fade. The driver calls it nothing, because by that point, the truck is no longer responding to the driver at all. The pedal goes soft. The vehicle accelerates. And the gap between the truck and the obstacle at the bottom of the hill closes at a rate the human brain is not equipped to process. For decades, the industry treated brake fade as a driver problem, not an engineering problem. If the brakes overheated, the driver had ridden them too hard. If the driver had ridden them too hard, the driver lacked training. The logic was circular. It protected the manufacturer and the carrier. It did not protect the motorists at the bottom of the grade. The solution arrived in stages, and always too late. Hydraulic brakes replaced mechanical systems in the 1920s and 1930s, improving consistency but not endurance. Air brakes, using compressed air to apply force to the brake shoes, became standard on heavy trucks by mid-century. They were more powerful, more reliable, and introduced a new failure mode, The compressor that pressurizes the air tank runs off the engine. If a driver overuses the brakes on a long descent, air leaves the system faster than the compressor can replace it. Pressure drops. Braking force drops with it. The system that was supposed to be fail-safe could be exhausted by the very conditions it was designed for. Engine braking, using the engine's compression as a retarding force, had been available since the 1930s. The Jacobs engine brake, patented in 1961 by Plessy Cummins, turned the engine into an air compressor on the descent, converting kinetic energy into heat through the exhaust manifold. Truckers called it the Jake brake. It was the single most effective tool for controlling speed on a mountain grade. It was also loud enough that hundreds of municipalities banned its use within city limits. Signs reading "No Engine Brake" lined the approaches to mountain towns across the West. The device that could have saved the most lives on the steepest roads was silenced by noise complaints. If you want to subscribe so you don't miss the rest of this story, now would be the time. The mountains did not change. The trucks did. Between 1950 and 2000, the gross vehicle weight limit for commercial trucks in the United States rose from 60,000 to 80,000 pounds. Engines grew more powerful, trailers grew longer, the loads grew heavier, but the braking systems did not scale proportionally. A 2014 study by the Federal Motor Carrier Safety Administration found that brake problems were present in 29% of all large truck crashes. Trucks with brake deficiencies were nearly 3 times more likely to be involved in a collision than trucks with properly functioning systems. Nearly 48,000 commercial truck accidents per year in the United States were directly attributable to brake failure. The geography concentrated the risk. Colorado's Interstate 70, the main corridor through the Rocky Mountains, drops from the Eisenhower Tunnel at 11,158 feet through grades of 3 to 6% for 30 miles before reaching Denver. The stretch between the tunnel and Morrison is one of the most dangerous for heavy trucks anywhere in the country. Greg Fulton, president of the Colorado Motor Carriers Association, put it plainly: Colorado has more runaway trucks than anywhere else in the nation. The state has 13 runaway truck ramps, gravel beds designed to arrest a truck that has lost all braking power. The most heavily used ramp in the nation is the Lower Straight Creek ramp on westbound the Ferd 70, near mile marker 212. In summer, it is used on average once per week. A tow truck company called Mountain Recovery operates 3 locations along the corridor, in Vail, Silverthorne, and Golden, with 19 trucks and 30 employees dedicated to extracting rigs from the gravel. Their founder, Charlie Stubblefield, has said that to reach a buried semi at the top of the ramp, his drivers sometimes have to launch their own trucks into the gravel at 50 miles per hour. Most runaway truck ramps in Colorado were built in the late 1970s and early 1980s. The trucks they were designed to catch weighed less and moved slower than the trucks using the road today. The ramps were a concession, an admission that the braking systems could not be trusted on sustained grades. But they only worked if the driver reached them in time, and the driver could only reach them if the driver knew they existed. On April 25, 2019, a 25-year-old driver named Rogel Lazaro Aguilera-Mederos descended Mount Vernon Canyon on I-70 in a semi-truck hauling lumber. His brakes failed. His employer, Castellano 03 Trucking of Texas, had received 30 safety violations in the 2 years prior. Some of those violations involved employing drivers who could not read English highway signs. The signs on I-70 warning of steep grades, sharp curves, gear shifts, and runaway ramp locations were written only in English. Aguilera-Mederos passed the Mount Vernon runaway ramp. He later testified that he did not see the last 2 signs for it, and that the ramp's configuration, running downhill and parallel to the highway rather than branching off uphill, was unfamiliar. By the time he reached the bottom of the canyon, his speed exceeded 100 miles per hour. He struck 12 cars and 3 other semi-trucks. The collision triggered a wall of fire visible for miles. 4 people were killed. 6 more were injured. Among the survivors was Malaya Harsh, an emergency medical technician who was pregnant at the time of the crash. She did not lose her baby. Aguilera-Mederos was convicted on 4 counts of vehicular homicide and 23 additional charges. He was sentenced to 110 years in prison. The sentence triggered a national outcry, but nearly 5 million people signed a petition for clemency. The trucking community called for a boycott of the state of Colorado. Governor Jared Polis eventually commuted the sentence to 10 years. The trucking company that employed him was not meaningfully held accountable. The road remained unchanged. The regulatory framework that governed truck braking was built for a different era. The Federal Motor Vehicle Safety Standard 121, which sets performance requirements for air brake systems, was first adopted in 1971. It has been revised incrementally over 5 decades, but its core structure assumes a world in which the driver is trained, the brakes are maintained, and the road is designed with adequate safety infrastructure. Each of those assumptions fails routinely, and when all 3 fail simultaneously, as they did on Avon Mountain, as they did on I-70, the result is not an accident. It is an inevitability that was documented, predicted, and allowed to occur. The Commercial Vehicle Safety Alliance conducts annual roadside inspections of trucks across the United States. Approximately 12% of all violations cited involve brake deficiencies, making brakes the most common mechanical violation documented year after year. A loaded tractor-trailer with out-of-adjustment brakes requires significantly more distance to stop. The difference can be measured in hundreds of feet. At highway speed, hundreds of feet is the distance between a close call and a fatality. Trucking companies operate on margins that reward speed over maintenance. Drivers are paid by the mile, not by the hour. Every hour spent in a repair bay is an hour of lost revenue. The Federal Motor Carrier Safety Administration sets limits on driving hours, 11 hours of driving within a 14-hour window, followed by a mandatory 10-hour rest. But enforcement relies on electronic logging devices that can be circumvented and inspection stations that are understaffed. The result is a system in which a 40-ton vehicle descends a mountain pass with brakes that may not have been inspected in weeks, driven by a person who may not have slept in compliance with federal regulations, on a road whose safety features were engineered for trucks that weighed 20,000 pounds less. The Avon Mountain crash produced consequences, but only after the bodies were counted. Connecticut passed a law requiring the Department of Motor Vehicles to be notified if insurance on any commercial truck was dropped. It became a felony for truck owners to operate without insurance. David Wilcox, the owner of American Crushing and Recycling, the company that owned the Mack dump truck, was sentenced to 6 years in prison for manslaughter, assault, and insurance fraud. Investigators found that his fleet had accumulated 448 mechanical violations between 1994 and 2001. He knew the brakes were defective on the day of the crash. He sent the truck out anyway. The truck driver died in the cab, trapped as the vehicle flipped onto its side and slid burning down the road. A surgeon on his way to work ran toward the flames and could not get close enough to reach him. Frank Juan, the bus driver, survived the initial impact. His spinal cord was severed. He spent the rest of his life in a wheelchair, in sweatpants, instead of the suits he had worn every day before the crash. His daughter said later that to her, her father died on July 29, 2005. He was buried in 2008. The state built a runaway truck ramp at the base of Avon Mountain, 700 feet of nets and cables designed to arrest a vehicle that had lost all braking power. It was the only ramp of its kind in Connecticut. Since it opened in 2008, it has been used once by a car. The Colorado Department of Transportation launched a public-private campaign called the Mountain Rules, producing video guides narrated in the voice of C.W. McCall, the singer behind the 1975 novelty hit Convoy. to teach out-of-state drivers how to survive the descent from the Eisenhower Tunnel. After the 2019 Lakewood crash, CDOT began designing a second runaway ramp in Mount Vernon Canyon. And with a $15 million budget and NASCAR-style barriers, the Mack brothers built their first vehicle in 1900. Jack Mack designed engines. Gus Mack designed transmissions. Together, they created a truck durable enough to haul artillery across the Western Front, to carry concrete for the Hoover Dam, to dig the tunnels of the New York City subway. During World War II, the Allentown plant delivered 35,096 vehicles to the combined Allied forces. The Bulldog became a symbol of American industrial might, unstoppable, unbreakable, built to move forward under any conditions. They built machines that could survive anything, except the one thing nobody wanted to engineer for: the descent. Mack Trucks still operates today, a subsidiary of the Volvo Group since 2000, headquartered in Greensboro, North Carolina. The Macungie Assembly Plant in Pennsylvania still produces every Mack chassis sold in North America. The Bulldog still sits on the hood. The heritage is intact, but the fundamental challenge that killed 4 people at the bottom of Avon Mountain in 2005 and 4 more at the bottom of Mount Vernon Canyon in 2019 remains embedded in the physics of every heavy truck that crests a mountain pass. Between 2000 and 2019, motor vehicle crashes killed 741,000 people in the United States. Among them were thousands of pedestrians, motorists, and truck drivers who died in crashes where brake failure was a primary or contributing cause. The industry responded with incremental improvements: automatic slack adjusters, anti-lock braking systems, electronic stability control. Each innovation reduced the probability of failure by a fraction. None of them changed the underlying equation: a 40-ton vehicle, a 6% grade, and a braking system that converts kinetic energy into heat until the heat wins. Somewhere on I-70, west of the Eisenhower Tunnel, a truck begins its descent. The grade is 6%. The load is 80,000 pounds. The driver downshifts. The Jake brake engages. The air compressor hums. The gravel ramp at Lower Straight Creek sits at mile marker 212, waiting. It has been waiting since the 1970s. The stone is deeper now than it used to be. The engineers have learned what works, but the fundamental truth has not changed since 1916. Since the first Mack Bulldog rolled off the line in Allentown, gravity does not negotiate, and steel does not forgive. If this story changed the way you think about the roads beneath you, consider subscribing. It helps more than you know.